That's what we're saying there. All right, folks, good evening. All right, so Carnival Wednesday, so we know things a little helter-skelter, a little bits and pieces, but we're on the inside, and we are starting the Jan 2024 Maths Paper 2. Yes, Mr. Liam. Hey, evening Liam, evening Donovan. How are you all doing today? Good to have you on. All right. Okay, so your man Liam vibes. D'Angelo here, Donovan here, Nifa here, Javier Jaziri, right? Jaquan, Jaquan there, Jolie there, Khalifa, Liam Logan, Nyla, PhD. Right, I feel as everybody, maybe one or two more might show up online. Aisha, Juliana, I didn't see Janaya. Right, I'm pretty sure Jaden and Noah, they didn't come to POA, so I shouldn't come to Maths. Josiah, I think them involved in other business, so anyhow, yeah, so folks, we're going to do it's only me today because Mishka, I'm not feeling too well today. So she said before she come and spread anything, and of course my laptop wants to be upside down. So hold on, give me 1 sec. Right, let me try that again. Rotate thyself. Nope, okay. Full screen. Well, you all could go ahead since you'll have the paper in front of you. Please and thanks. Don't wait on the eye. Because when I start and it's peace, we know what to go on. Right. Let me see. Up at the top. Come the man, leave yourself. Hold on just now. Display. Okay, I know it takes so long for settings to open up, but all right, cool. It's on strike. Landscape flipped. Right, which means all again it inverted there. All right, so let me see. Hold on. Have I vertical and horizontal? Right. I think we online boys on there. It have a part of the fortnight coming out for fifth night. Is that a prequel? Yeah, what the prequel calls? The prequel was called last night. Yeah. Left eye, right eye. Is that optician? Is that optometrist? That's mine. As a heartbreak semester, the real first calculator, boy, what kind of screen on? You could swipe on another calculator. What? Yeah, you're gonna be doing. Right. What is the question, right? Well, yeah, let's spell it out. Pura? Hanine and Kaline. Well, it's a good thing we're recording our laugh because if I describe anybody, it'll never be me. Better put on the replay, boy. All right, folks. Right. So, answer all questions, all working must be clearly shown. Now, this is only 2 marks, so don't go overboard with the working, but please do obey the instructions. Express as a single fraction in its simplest form. So when this is simplest form, what they want you to do, hopefully, is to reduce it or to cancel it down. Correct. All right, so let's see what happened in there. So, as you know, with respect to what happens first here, the items in the brackets happen first. Hold on, sorry. Google Meet. Right, D'Angelo, Donovan, Liam. Right, okay. I'll just see if anybody else is kind of knocking to come in there. Right, so when you're adding or subtracting fractions, we need a common denominator, right? Now, between 30 and 15, 30 is in fact the lowest common multiple. Oh, here's Christian. There's Christian here. And put that Christian is present today. Hey, good evening, Christian. How you doing? How was your English presentation today? How it went? Right. So we do need Jan 2024, paper 2. This is question 1, part A. So we're now going to starting, right? Right, so yeah, again, when you're adding or subtracting fractions, we need a common denominator between 30 and 50. So if you're not sure how to find a common denominator, you could do this, right? I don't know if maybe what they showed you in primary school, but you could do this, right? So come the man Philip yourself. Just now, it'll pop back up shortly. Come back up yet? It's gone for everybody, but things bad in the camp. Hold on, just now. It's resizing, reshuffling, right? Nice. Again, Philip. You're behaving bad today. Hold on, 1 second. That's the case, I'm going straight to it. Direct tweet. So I don't know what the story is with that, why I'm doing that, but give me 1 second. Right, Google Meet, be visible, back in the dance, all screens visible. See that screen showing in the corner there? All right, cool. We up on board here? All right. Let's try that again. So if you have 30 and you have 15, right? What number could go into both 30 and 15? Let me say 5, right? 5 into 30 goes how many times? 6, and 5 into 15 goes how many times? 3. And then between 6 and 3, what's the next common factor between 6 and 3? 3, right? So 3 into 6 goes 2 times, and 3 into 3 goes 1 time, right? So here's the next one, right? 2 could go into 2, right? 1 time. So what you do now is you multiply going down. So 5 by 3 is 15, 15 by 2 is 30. Or 3 by 2 is 6, and 5 by 6 is 30. So that's how you get your LCM, right? So we could identify the LCM as 30. But the question is now, how do we turn, hold on 1 second. What's going on here? No, we okay. All right, sorry. I thought something had blanked off on the side. Yeah. Right, so how do we turn 15 into 30? Right, so check it. 30 could factor, as we saw, as 2 by 3 by 5, right? 15 is 3 by 5. What is missing from here that is here in that list of factors? The 2. So what we do is we multiply by the 2. But you have to multiply, sorry, I thought I changed the green. Yeah, you have to multiply both the denominator and the numerator by 2. So 15 by 2 is 30, but what's 4 by 2? 8. And that's how we get the numerators to conform, right? 4 by 2 is 8. And what's 1 plus 8? That's 9, right? And can 9 over 30 simplify? Can it cancel down? What's the common factor between 9 and 30? 3. 3 into 9 goes how many times? And 3 into 30 goes how many times? 10, right? So now all of that was in the bracket. And what's this symbol here? Minus, right? So it's 1 minus 3/10. So if you think about it, you could write 1 as 1 over 1, right? And that could become any fraction over it, any number over itself. So if you're subtracting 3/10, we could turn 1 over 1 into 10 over 10. And what's 10/10 minus 3/10? 7/10. Right, okay. So that's the first piece there. Right, now again, if you have a calculator and you're plugging it in, the first thing you would do, now you could plug in the whole thing as it is and it'll spit out the answer. If you put just the answer, you will not get your full 2 marks that is awarded for the question. You get a mark to a mark and a half for the working, and a mark to a half mark for the final answer. So the bulk of the marks you get is in the the working. All right. That's that piece there. Now, down here, it's saying a 2-story car park has a total of how many spaces there? 1,020. At 60, come on, man, Philip, give yourself. Just now, sorry. All right. At 6:30 hours one morning, 1/30th of these spaces are filled. During the next hour, no cars left the car park, but another 4/15 of that same 1020 spaces are filled. Determine the number of parking spaces that are not filled at 7:30. Okay, cool. So they want the number of spaces what? Not filled. So this reminds me of a SCA question. Steps on the SCA. So I see some of these questions here. So let me just highlight what it is that they want us to actually show, right? Determine the number of parking spaces that are not filled. Okay, so what's the overarching logic here? How many spaces in total we have in the parking lot? 1,020, right? So total available spaces equal to 1,020. Sorry, my bad. And if you want to, and if a certain number of spaces are filled, how do we find out how many spaces are not filled? For example, let's say out of those 1,020 spaces, let's say 20 were filled. How many spaces not filled? Yes, Abby, that's correct. Very good. Hello, anybody? If you have 1,020 spaces and 20 are filled, how many are not filled? 1,000. How you got that? You subtract it. Right. So the overarching logic is to find out the number of spaces that are not filled. You subtract, you take the total spaces of it, so total available, and you minus the filled, right? And that will give us the not filled. Do we agree with that? Right. Okay, so the total number of spaces is 1,020. Now, 1/30th of those are filled, and then another 4/15ths. Right? Now, it's not 4/15ths of the remaining spaces, yeah? It's another 4/15ths of the same 120. Right? Now, tell me something. We have 1/30th here and 4/15ths. Where we saw those two numbers before. We didn't just see them in the previous part of the question. Aha. So, if you take 1/30th and add 4/15ths, what we got last time? 1/30th plus 4/15ths is actually 9/30ths or 3/10ths. So, if 3/10ths of the spaces are filled, how do you find how many spaces that corresponds to? Right? So 3/10ths of what number? 3/10ths of 1020 are filled. Right? So the zeros could cancel. What's 3 by 102? What's 3 by 100? 300. And what's 3 by 2? 6. And what's 300 plus 6? Savage, that's correct. Very good. 306. So you have 1,020 minus 306. What's 1,000 minus 300? 7. And what's 20 minus 6?
Coachman.
Coachman?
Sir, I never do that.
I never do it.
All I will do what I guys say, man, sir.
Okay, how did you do it then?
I'm over 20 plus 4 over 50.
Right?
And then 7
Mm-hmm. Well, hold on.
Sure, sir?
1 over 30 plus 4, 15 is 3/10ths. Right? And then you subtract that from 1 and you get 7/10ths. So something in the mix that you messed up because we said 1 over 30 plus 4/15ths and then from there was 7/10ths. Right?
Oh, yeah. Same coach, man.
Yeah.
Coach, man.
Right. The 714 spots are not filled. Now, now that's 1 mark, eh? So notice there's only 1 mark, so it can't be too much working. This is working is sufficient for 1 mark. Right? Now, of the 1,020 parking spaces, 20% on the top level. How many parking spaces on the top level? So how will we find that? Of the 1,020 parking spaces, 20% are on the top level. How many parking spaces are on the top level?
20% multiplied by
Yeah. 20%, 20 over 100 multiplied by 1,020. Right, so that's 204. Well, that's the remaining spot. That's how many are not on the top level. Well, just don't forget, it have no extra marks awarded. So, either you answer the question or you didn't answer the question. It's binary, right? Okay. Ladies, are we okay with these two things here? Any questions, anybody, anything? No? All right, gentlemen, are we okay with that?
Yes, sir.
All right, Paige, Nyla, Leon. Yes? No? Maybe? All right. All right, Google Meet. So, Christian, D'Angelo, Donovan, Liam, and Logan. Right, if you're good with that, give me a Genie chat. If you need me to re-explain, repeat anything, give me a R, but then tell me specifically what you want me to repeat. All right, okay, I got my quota G's there. All right, I'm going to just number a little more water, and I'll put it in the next part. That's a good question, but maybe he was answering the question just now. So at that point in time, right, it was justified. I'm not sure what's going on right now. All right, cool.
Easy up. Hey, Chris, I'm trying to listen to Chris.
Well, given that drinking water, that might be a bit hard to do, but all right, cool. Right, so let me start talking. So some of these spaces, so part D corresponds or pulls from B and C, right? Shh, you say you're trying to hear me? I talking? Right, good. So some of these spaces are reserved for monthly paying customers. The ratio of reserved spaces to non-reserved spaces is 5 to 7. But right now it's 7 more 2. Different story, right? So the protocol with ratios is you add the two numbers together. 5 plus 7 would give us 12. And then you'll take each of the numbers and put them separately over the total. So it's a 5 12, 7 12 split. Right? So the ratio of reserved to non-reserved is 5 to 7. Right? So 5 12ths of the spaces is reserved. And 7 12ths is non-reserved. Now, how many spaces were there in total again? Right. So some of these spaces. So there was, hold on this now. That's too big. Right. So there was a total of 1,020. Right. So calculate the number of non-reserved parking spaces. Yeah. Yep, that's correct. 590. All right, cool. So let me give them a chance. Divided by 12.
No, I don't need this one. Don't tell me, it's not pretty boy. I don't need that. I need the strong one there. Strong one for the boy. Hey. What?
Oh, hey Solomon, how you doing? All right, Lauren, Alexis. Hey, how you doing, Lauren? Subtract is correct. Very good. You sample VIX often? Or? It is in a VIX, so let's ask if you sample VIX often. The opposite has happened. I smell things, thought I knew what it is, and it is quite different. Like coffee. Coffee smell real nice. It don't taste like that. It's just bitter. I drink it because I need to stay awake. What's that, coffee?
Yes.
You looking to dead? You looking to see Jesus today? All right, cool. Right, so what we're going to do is find 7 12ths. So the non-reserve is the green one, right? So that's 7 12ths multiplied by 1,020. Right, so again, you can plug it in your calculator and I'm not sure how to pronounce the name. Leon? Is it Leon? Am I wrong? Right, 590 is correct, right. Right, so if you want to work it out long ways, you're very free to do that if you plug it in your calculator. And again, some of you all don't have the scientific calculators, and I would strongly suggest you get them sooner rather than later. I just see my partner here working with us, so they did a good job on that. right? Because when you go for mock and you walk into the exam room, you cannot walk with your phone, right? It will get taken away. Yo. Well, you see, some of them don't know what they're talking about, right? Because the only ones that are banned are the programmable ones, right? Okay.
So what she told me was banned, so I was like,
Well,
I can't do anything more than that.
yeah. Anyhow, so you could, if you know how to plug it in using your fraction button, go ahead, right? For those who, if you find yourself in a situation in the exam where you don't have a calculator, yeah, go ahead. All right, good. Well, make sure it stays sharp and not, and don't get done. Well, you know, I think I had mentioned this on Monday, but one of the guys who does lessons online with Mr. Cooper, my teacher who works with me now, he did January exams and he went to the exam place and they said, no, we don't do exams. I think we was talking about on Monday, right? Yeah. So you had to scramble and find where to go. Right? Is Casio allowed? Yes, Casio is allowed. It's only non-silent, non-programmable calculators are allowed. Right? So just make sure it's non-programmable. It should be okay. Right. So again, if you don't have a calculator and you need to use your brain, right? You can do 2. 2 into 12 goes how many times? 6. 2 into 10 goes 5 times, and 2 into 20 goes 10 times. What about 2 again? So 2 into 6 goes 3 times. 2 into 5 goes 2 remainder 1. 2 into 11 is 5 remainder 1. 2 into 10 is 5. What about 3? Now, how do you know the shortcut to know if a number is divisible by 3? Chris, I can bring my calculator. Yeah, of course. Yeah. To know if a number is divisible by 3, add up the digits in the number until only one digit remains. What's 2 and 5? 7. What's 7 and 5? 12. And what's 1 plus 2? 3. If you do that and you get either 3, 6, or 9, the number is automatically divisible by 3. All right? So 255 is divisible by 3. 3 into 25 goes in 8 times, going over by, what remainder 1. And 3 into 15 goes 5 times. So now we have 85 by 7. And again, you could split this up into 80 by 7 plus 5 by 7. What's 80 by 0 by 7 is what? 0. 8 by 7 is 56. And what's 3 by 7? 5 by 7, 35. And 560 plus 35 is equal to 595. Right? So again, I'm just doing it. Oh, hey, good night. How you doing? Brand 12 _1. Yeah. This is just for illustrative purposes. In the event you end up in the exam and your calculator either conk out or you forget it. Any for you, all right? They went honey near to him. All right, cool. This is CXC. Yeah, CZAC. All right, okay. Part E now. The cost for parking at the car park is shown in the table below. So if you park under 30 minutes, hey, it's free, boy. What? I could use that, boy, when I go to pay my PAY and thing. Right, more than, so between 30 minutes and 2 hours is 225. Between 2 hours and 4 hours is 550. More than 4 to 8 is 925. 8 to 24 is 15. 1 week ticket is $40, boy. All right. Michaela leaves the car park at 18:30 and pays $9.25. Determine the earliest time she could have arrived at the car park. Oh, is that backwards working here? All right, cool. So if she had to pay $9.25, which of these category she fall into? All right, yeah, that's this one here, right? More than 4 hours and up to 8 hours. So the maximum time she could park and pay $9.25 is how long? 8 hours. So 18:30. Right? If you had to go backwards, it is minus the 8. It was 18:30 minus 8. 10:30. Right? So 18:30 minus 8 hours gives us 10:30. So the earliest time she could have parked there and drive out and pay only $9.25 is 10:30 in the morning. Right? 18:30 is 24-hour clock. Right? So what they do is they'll come 1 to 12 and then they'll get 13 o'clock, 14 o'clock, which is just 1 p.m., 2 p.m., etc. If you're ever not sure, that's minus 12 from the hours. And then put a PM. Right? So this, once again, she paid $9.25. That puts her in this bracket here. The maximum time for which she could have parked was 8 hours. Right? And they wanted the earliest time she could have parked. Right? And the minimum time would have been the 4 hours. Right? So 18:30 minus 4 would be 14:30. That's 2:30 p.m. But they want the earliest time. Is 2:30 p.m. earlier or later than 10:30 a.m.? Later. It's not the earliest time. Right? Oh, hush. Right. Now, Dan Raj. Dan Raj bought a weekly parking ticket for $40. All right. That week, he visited the car park 5 different times. The length of time he parked his car on each occasion is given below: 25 minutes, 7.5 hours, 11 hours, 8.75 hours, and 8 hours. Show that Dan Raj saved $8.50 by buying the weekly ticket. Now, that's 3 marks. Right? So, how do you propose to go about showing that Dan Raj saved $8.50 by paying for the weekly parking? Or if he didn't pay for weekly parking, he'd have to pay for each time. So what you could do is find out how much he would have had to pay for each of those stays, right? If it was 25 minutes, how much do you pay for 25 minutes? It's free, right? So $0. 7.5 hours. $9.25, okay. Right. 11 hours. Or shouldn't you say 11? ELEBM. 15. Shouldn't you also say correct? And contact us. Apparently we drop off letters. Anyhow, sorry. 8.75 is how many? That's at 15 again. All right. And 8 hours is $9.25. Yeah. Because it's up to, if you look at up to, so more than 8 and up to 24 is $15, right? But if you stay exactly 8, you pay $9.25. Okay, so what I want you to do is add up all those and see if you get what's that. 18.50 plus 30. 18 and 30 is 48. Yeah? Okay, so add it up and see if you get 48.50. Right, so plus is equal to $48.50. So if he had paid for each of his individual stays, he would have paid that much money. But because he bought a weekly parking ticket for 40, you only pay 40 for the whole thing. So you'll subtract. And you'll get 850. Right. But as this funny part is, this has to jump up, is to come down. They just jump up. Anyhow, Google Meet. If you're good with part E, as in the stuff on the screen, give me a quick Genie chat, please and thanks. Right? I was assuming you were good with part D because that was kind of straightforward. If you need me to rework, give me an R. But if you're good with what's visible, give me a quick G. All right. All right, Ziana, we go with that. You okay with that? All right, Paige, are we cool with that one there? All right, cool. Ladies, we okay with that? Questions? Paige, talk to me. Yeah. Truly working clearly. Yeah, that's fine. Okay. Right. So with that, let me go on to the algebra part of the paper. All right, so I'll zoom in here. I'll give you all a couple of seconds to get a little head start. I'm gonna drink some water. Oh yeah, so you get for party then. Oh, that's a good idea. 2 party, yeah. X over X subtract 7. All right. So talk me through how you get that. Right.
X squared plus 7x
Right.
over x squared subtract 2 minus 49.
Well, that's what they give you. Okay, cool. All right, go ahead. Right. Yeah, that's the question.
So ix and then I put brackets x plus 7. Plus 7.
And what do you call that process? What do you call the process of going from here to here? Factorization. Yeah. If you're seeing one in the front there, then the answer is yes. If not, hold on.
was going, yes, it's just about two, so I was going. Get off left, in love. Sige, bye. Sige, bye.
Let's check that denominator again. Right, so x squared minus 49. So we're factorizing. There's a special name given to that. Right, correct. Factorization is correct. So when we see something in the form, now tell me something, x squared is x to the power 2, which is x by x. When you multiply something by itself, we call that squared, because it's basically finding the area of a square with that dimension, that magnitude for each of them,
I
right?
didn't use that one, but I don't know.
But it's not this question we do. Oh, factorize. Okay, cool. Right. So x squared is the square. What about 49? Is 49 a square? 7. So we have x squared minus 49, which is the same as in x squared minus 7 squared. That's called the difference of two squares. And how we factorize the difference of two squares is, so if we have a squared minus b squared, the difference of two squares, the factor it or the factorize it, you find the square root of the first term, put that first in both brackets, find the square root of the second term, put that second in both brackets, put a plus in one bracket, and a minus in the next one. Doesn't matter if you put the plus first or the minus, first. Once you put a plus in one bracket and a minus in the next one. So now the denominator looks like this. X plus 7 by x minus 7. And guess what we could do? We could cancel this item with that item. And that would leave us with what? X over x minus 7. Very good. Okay, this one down here, if in case anybody can't see it too clearly, right? It says, okay, I'll write it out on this side, right? It says x squared multiplied by x to the power 6 is equal to x to the power r, and they wanted to find the value of r. Now, according to your laws of indices, if you are multiplying and you have the same base, what do you do with the indices? Yeah? Yeah, add them. Very good. So we have x to the power 2 plus 6 is equal to x to the power r. And what's 2 plus 6? Whoa, whoa, whoa. What's 2 plus 6? 8. So if x to the power 8 is equal to x to the power r, what can we deduce about the value of r? R must be equal to... Gosh, very good. Good job. R must be equal to 8. Okay, how are we feeling with the algebra section so far? Doable? Decent? Yeah? This one down here, they said determine the value of s when s cubed is equal to 8. Let me write that one over. Right? Yo. Sorry. Yeah. Right. So hold on, let me. Right. So if s to the power 3 is equal to 8, how do we find s? We have to undo the cube. Right? That is correct. Camera. Leon? I'm trying to figure it out. Okay, that is correct. Right? So s cubed, right? So it's s. So when you cube something, you're multiplying 3 instances of that item together. Right? So s cubed is s multiplied by s multiplied by s. Right? Gotta find the, well, not the square root. And it's actually interesting because you have a power of 5 next to your name. That's pretty cool. How do you do that? I would love to do that. Right. Now, so one way is you could do trial and error, right? So let's start with 2. What's 2 by 2? And what's 4 by 2? Ah, well, look at that. Therefore, s is equal to 2. Now, the other way that you could do it, oh, sorry. Cube root, very good. Yes, it's cube root. That's correct. Right. Right, so the other way to do it, right? So let's take a different case to see if we could jog your memory, right? If I told you x squared was equal to 25, and I ask you, what's the value of x? You tell me 5. And I say, well, if you had to have an operation, you'd have to undo the square. How do we undo a square? By finding the square root. And of course, whatever happens on one side must happen on the next side as well, right? So to undo the square, the cube root, to undo the cube power 3, you have to find the cube root. Right? Now, most of the more recent calculators have a cube root function on it. So you could plug it in, and we just get that s is equal to 2. Right? So you have different ways you could work it out. All right. Okay, cool. So let me just zoom out a little bit here. Actually, I'll just zoom back. All right, Google Meet. If you guys are good with what's visible, just give me a quick Genie chat. All right. If you need me to re-explain the first part with the difference of 2 squares, give me an R. Well, give me an R for anything you want to re-explain. But the other tell me what you want to re-explain, right? Thank you, Trey. All right. All right. All right. All right. Hanifa, Khalifa, and Julia, are we okay with what we have on the screen there? All right. Jaquan, Jaziri, and Javi. So it's J is all around, boy. All right, cool. Paige, Nyla, and Zayan. You okay with that, please, there? All right. So. Right, so Christian and Donovan. Let me know we're going on with this question now. If you need me to re-explain any particular part of it. Okay, cool. Oh, thank you, Trey, and thank you. Oh, where's Ash? Okay, yeah, all. Thank you very much. Okay, going again. 2 part C. Aha! Look what I did here. They combine algebra with some geometry. So some shapes. So let's take a little read here and see if we can talk to it, right? So it says the diagrams below show a triangle and a quadrilateral. How many sides does a quadrilateral have? 4. A triangle has 3. And not only that, they each have that same number of angles. A triangle, tri is 3, and angle is angle. So it's a 3-angle shape. A quadrilateral also has 4 angles. Now, what we are seeing inside here is not values, but expressions, algebraic expressions. Yeah. Now, it says here for the triangle, we are seeing algebraic expressions for the angles. So tell me something. What is the sum of the interior angles of a triangle supposed to be? 180. So if we were to add those 3, we should get 180, right? What about for a quadrilateral? The sum of the interior angles is? Right, so for the triangle has 180, and for the quadrilateral has 360. So for the triangle, show that 2a plus 5b is 171. So what you probably should do here is you should probably add up each of these expressions. Add all of those expressions together. Now that's the sum of the interior angles. And we know that the sum of the interior angles of a triangle is equal to 180. Oh, very good, Trey. And Anki Morale. And something like that, right? Good. And cash, right? So you add up all 3, you simplify as fast as possible, put it equal to 180, and maybe you could somehow get to the 171. And then the same thing for the quadrilateral. The sum of all the angles, right? You add all of them together, put it equal to 360, and you should be able to simplify to that. All right, so I'll give you a minute or 2 to see if you could arrive at that particular answer, and then we'll go from there. Gotta disregard. Go pop up a little screen, you know. Yeah. How to spell it? Yeah. It have a fella called the referee, right? Is he one in the white and black? Well, they have different colors, right? Yeah. Right, and there's 10 men and a bully. It's like a boxer check. It's a right wing, left wing, center breast. let's have what else, boy? Ah, so it's an equilateral triangle, which means all of the lengths are equal and all of the angles are equal. And what is some of the interior angles of a triangle? So if they're distributed equally, 180 divided by 3 is 60. And if you drop a perpendicular here, you actually cut it into equal halves. So you'll have a 30 on top, a 60 down here or down there, and then a 90 here. No problems. All right, let's see what we came up with. So it doesn't matter the order in which you put them or you write them, because we're going to be adding. So we have A plus 2B, and then we have 3B, then we have A plus 9. And then you could rearrange and bring together all the like terms. So you could put the two A's together, so we have A plus A. You could put the B's together, you have 2B plus 3B. Oh, sorry, and you were supposed to put equal to 180. Don't forget that, eh? Now, what's A plus A? 2A. 2B plus 3B will give us. Now, look at that. We almost there, right? But that was the next thing to do. They put plus 9 is equal to 180. And the thing that they gave us, they only have algebra on the left-hand side. So we have to remove the 9. How is the 9 attached on this side? Addition. To remove something attached by addition, we need to use the opposite operation, which is subtraction. So if you subtract 9 from this side, it'll cancel the 9, leaving us with 2A plus 5B. And whatever happens on one side of an equation must also happen on the other side of the equation. So we'll minus 9 here too. And 180 minus 9 will indeed give us 171. All right. Okay, so I'll give you a minute or two again if you want to try your hand at the quadrilateral one. Right, so you're going to add up all 40 angles, put it equal to 360, and then simplify to see if you get that. Well, it's an equation, but it's also an expression there. Well, it's an equation. This is an equal sign. Hold on. Okay. Let's go ahead with this one, shall we? Sorry, just give me 1 sec. Yeah. Right. Okay. So again, I'll just start with the top left corner and we'll go clockwise, right? So 6A plus 3A plus 2b plus 18 plus 3b plus 3b minus 2a is equal to 360 degrees, right? Okay, so we have 6a, 3a, and minus 2a. What's 6 plus 3? 9. And what's 9 minus 2? 7. So the a's could simplify to 7a. Now, with the b's, you have 2b plus 3b plus 3b. 2 plus... That's not much. That's sufficient work for 1 mark. All right. So that's 8b. You really had to ask them how they distribute the marks, you know. I have a feeling what happened, I believe, is that different people said different questions. And the people, and some people have different ideas about what should be worth 1 mark, depending on the topic, right? Right, and don't forget we have to add 18 here, right? And this is equal to 360. So of course, now to get to where we want to go, which, and of course we're almost there, we have to remove the 18. To remove the 18, we have to subtract it from both sides, right? So again, if you subtract 18 from this side, now if you want to see what it actually looks like, right? So this is the part they don't usually show you. They say, well, carry it over the equals sign and change the sign. But it's not the best way to explain it, but it's quite efficient, so I understand, right? Whatever you do on one side, you must do on the next side as well, sorry, right? So you're minusing the 18 on this side and on this side, right? So ultimately, what it will give you is 7a plus 3b equal to 342. Okay. Right, 3. Yeah, 3. Yeah, I hear you. I think so. I think there's a bit of a lack of consistency, or maybe a lack of something. There's a lot of lack on the part of C-secondary exams. Right. Okay, Google Meet. So Logan D'Angelo, Donovan, Christian, and Liam. If you guys are good with that, just kindly give me a quick G in the chat. All right, thanks, Liam. All right. Now we're not done, eh? Now it says solve the pair of simultaneous equations in 1 and 2 to find the values of a and b. Show all working. So what I'll do is I'll put the equations in part 3 down there. So that way we could just kind of stay down there. Ah, yeah, sorry. No? Okay. Right, so we have 2a plus 5b is equal to 171, and 7a plus 3b is equal to 342. Now, the interesting thing is that 342 is equal to 2 times 171. So if you double this and get 4a plus 10b, that's actually equal to this. But I think that's something as a different one. Oh, was it 8b? Sorry. Yeah. Sorry. My bad. Thanks very much. My bad. I know where I get 3 from now. Pressure in the dance. You see why it's important to check over your work and make sure you write the correct thing? Right. The biggest something followed. Oh, thanks. The biggest, I don't know what this is. Thanks for the follow. All right. So again, I'll give those who may want a minute or two a little head start. Those who don't know what to do, just relax. Or you could move ahead in the paper and see what else you could do, right? So again, just to remind you, in case you forgot, when you're in the exam, if anything given trouble, leave it and come back to it, right? But make a note to come back to it, right? It doesn't matter where you get the marks in the paper. The marks in the paper are all equal, right? The amount of work or the difficulty to get certain marks might differ. That's par for the course, right? But whether you get a mark in question 1 or a mark in question 2 or a mark in question 10, it matters not, right? You want to get as many marks as possible, right? The advantage of going in order is that you don't really miss out stuff. If you jump all over the place, then you have a chance you might omit a question or 2 or more, which you don't want to do, right? So always keep track of what you have done, what you have left to do, and make sure you have a visible timer in the exam with you. Whether it's your watch, I don't know if you could carry your own clock. You could carry your watch. You definitely can't carry your phone, so don't worry about that, right? I used to take off my watch, put it on the side, so I used to look up and see the time, right? And of course, to make it easier on your brain, make sure it's a digital watch. If it's analog, make sure it's clear, and you don't have a set of dials, so you have to figure out what time it is, right? The less brain power you have to divert and come back is the better for you. But always keep track of how much time you have, right? There's 10 questions on the paper, and how long you have for the paper? 2 hours and 40 minutes. How many minutes an hour? 60. 60 by 2 is 120. 120 plus 40 is 160. So that's about 16 minutes a question. Let me say 15. All right? I have an extra 10 minutes for reading. All right? Yo.
Okay, I'm gonna check the 5 minutes. 4 hours. I'll check my access on it.
I didn't know what to say about him again, no. That's why, yeah.
No, because the thing is, he never said anything for us to do with
Hmm.
So, like,
I don't know how to help you either, so. What's it? FF? No, it means, okay, you know how you can have FG? Right. So if you have FG, you plug in G into F. If you have FF, you plug in F into itself. And sometimes how they'll put that, they'll put F on what looks like a power of 2, but it's not a power of 2, it's F. Right? So if we did multiply that by 2, we'll have 4 and 10. If we were to subtract that, that's 3a minus 2b is equal to 0. 3a minus 2b is 0. 3a is equal to 2b. A is equal to 2b. So if we scale it up by 4, that's 12. So that's 19. So is that then 7? No, cap is 19 by 8. By 8, yeah, okay. I guess I'll give you, yeah, what question? Oh, right. I'll give you about a minute again, and I'll start checking something here. Okay? Quiet. Go back there. If you want to save that. No! What are you doing? Go back. Go back to where it was. Pretty cool. That's real nice. How do you do that? Okay, I'm confused. Whoa. All right, guys, let's go. All right, so with simultaneous equations or simultaneous linear equations, we have different methods by which you could solve. Shh, we're on the screen. Right. So we have elimination, we have substitution, we even have a matrix method, and you have a graphical method, right? And you have other little things you could play around with. But of course, it's 3 marks, so you don't want to overdo it. And if you look at the space you have, it's not that much. Now, if it is, you needed more space, right? You could go to the side if it have a little bit more on that side, right? But always obey where it says, do not write in that part there, don't write in that part there, all right? I remember this fellow couldn't fill out forms to save his life. They started by putting surname and he put teacher name.
What?
I can't see the next part. I'll look at them inappropriate. And what was the next one he put? He put his first name. It had a part when they said for official use only, he put okay. So please know how to fill out forms. Boy, here now. Right. So let's label these things equation 1 and equation 2. Equation 1 and equation 2, right? So, long story short, basically, when you are solving for unknowns in algebra, you need at least as many equations as there are unknowns. How many unknowns we have here? We have 2, A and B. How many equations do we have? We have 2, so it's workable. If you only had 1 equation, but you had 2 unknowns, you couldn't solve, right? If you have 3 unknowns, you need 3 equations. If you have 1 unknown, 1 equation is sufficient, okay? So you need at least as many equations as there are unknowns. So do we have that? Yes, we do. We have 2 unknowns, 2 equations. Brilliant. The next thing is we can only solve for 1 unknown at a time, right? So we either have to solve for A or B and then go back and solve for the other one. To do so, it means kind of eliminating or getting rid of one of them. Okay? Now, whether you use substitution or you use elimination, either way, you're going to kind of get rid of one and just, you're going to get rid of A or B and work with it. So if you get rid of A, you're going to work in terms of B. If you get rid of B, you're going to work in terms of A and solve for A first, right? Okay, so long story short, I prefer elimination because it was the first method I was taught, and substitution only really works efficiently if you have a coefficient of 1 for any of the variables in any of the equations. In both of these equations, are any of the coefficients 1 or are they all other than 1? They're all other than 1. In equation 1, we have 2 as the coefficient of A. In equation and 5 as the coefficient of B. And in equation 2, we have 7 as the coefficient of A and 8 as the coefficient of B. So to me here, substitution wouldn't be very efficient. You'd have to work with fractions. Now, I'm not saying don't work with fractions here, other than 1. That's correct. Yes, 3. Right. So I'm not saying don't work with fractions. I'm saying just be careful, right? So what elimination does is that we have to equate the coefficients. So first, you have to choose which one you want to eliminate. Let's use B. Let's solve for A first. So to solve for A, you have to, right. So to do that, basically what you have to do is you have to multiply each equation by the opposite coefficient. What I mean by that? So if we try to eliminate B, what's the coefficient of B here? 8. So what we would do is you take equation 1 and multiply it by 8. And then for this one here, you're going to take that equation and multiply it by 5. So you're multiplying each equation by the opposite the coefficient of the variable that you're trying to eliminate in the other equation. A lot of words, right? And so you're taking equation 2, multiply by 5, right? So again, it's like you're taking these two numbers and you're multiplying each equation by the other one. So you're multiplying in equation 1, you're multiplying by the coefficient in equation 2. In equation 2, you're multiplying by the coefficient in equation 1. Okay, so let's do equation 1. So you're multiplying everything by 1, sorry. And to know if you're adding or subtracting, look at these signs here. If they have the same sign, you subtract. This is the same sign, so we subtract it. If we don't have the same sign, we can't subtract. And if you can't subtract, the other option is to subtract is minus. You have to add, right? So if you have if you had a plus in one equation and a minus in the next one, you'd add. If they were both pluses or both minuses, you'd subtract. Okay? So you'd subtract. So was 8 by 2? 16. Was 8 by 5? 40. 8 by 171. That's 800 plus 560 is 1360 plus, so 1368. Please feel free to double check my arithmetic. All right, thank you. Right, the next one, you're multiplying this one by 5. So 7 by 5 is, as the man said, 35. 8 by 5 is 40. What do we notice about these two numbers? They are the same. So when we go to subtract, we're going to be able to eliminate them. This by 5 as 1500 plus 200 is 1710. Right, so we're going to get some negative numbers, but that's fine because, right, so 35 minus 6 is minus 19a to the front. 40b minus 40b is 0. 1368 from 1710. So that's, I think that's minus 442. Minus 342, sorry. Yeah, because you need 32 to get to 1400, and then you need 310 more. Yeah, so 32 plus 310. Yeah, 32 plus 310 is 342, right. So if minus 19 is equal to that, so to solve for A, you have to remove the coefficient of minus 19. How is the coefficient attached? What operation? Multiplication. To remove something attached by multiplication, what do? We use the opposite operation, which is division. Right, so I'm figuring, what's that, 27? It can't be 37. 30 by 20 is 600, I guess, right? 20 by 400, so maybe it's 18. Because 19 by 19 is 18, right? So A is equal to 18. Well, maybe not, A is 18. Now, after you have solved for A, you could go and solve for B. How do we solve for B? by substituting the value of A into either of the equations. Ideally, both of them so you could cross-check to make sure you get the right answer, right? So we're going to say substitute A is equal to 18 into equation 1. Now I'm going to do both equations. B is 27. All right, well, let's check it out. Let's see if 3 is correct. All right, so let's see. Right? Right now, Google Meet, don't forget, you can send me pics of your work, you could put suggestions in the chat and then, right? I know I forget to tell you how to do that, but as assume you know, but yeah. If you feel so inclined, please feel free to do that. Now, my WhatsApp is working too good, notifications not popping up, so I gotta go and check. So I'm going on a weekend change now, so it's quite inconvenient. Yep. It wouldn't be wrong, no. Okay, hold on. For which item did you substitute, A or B? And which equation did you use to make 80 solid? Equation 1? Okay, so that would be 171 minus 5b all over 2. Right, and you would have put that by the 7, right? Okay, cool. So that would be 7 plus 11, 1197 minus 35b all over 2. Then plus the 8b. And then that would be 16b. Because when you simplify, or when you multiply by 2 to clear out the denominator, no? Or even if you simplify it, you had to still find a common denominator. Mm-hmm. You could do that too. It's not supposed to work out imprecise. I'll come and check this. Now I'm finish up what we're doing here, right? Okay, so what I mean by this is you're going to put a 2, then multiply by 18 plus 5b equal to 171. Now 2 by 18 is 36. To solve for b, you have to remove or undo everything attached to the b. So let's start with the 36. How is the 36 attached to the b? By addition. To remove something attached by addition, we use the opposite operation, which is subtraction. So we're going to subtract 36 from both sides. When you subtract 36 from the left side, it'll disappear, cancel the 0, leaving us with 5b. And 171 minus 36 will give us 135, I believe. And now to remove the 5, it's attached by multiplication. And to remove something attached by multiplication, we use division. So 5b divided by 5 is just b. And then 135 divided by 5, I think is 27. Yeah, that's what, yeah, Shri and Kamaral. Cool. Good job. Now, if you wanted to triple check your work, what you could do is sub it into equation. Sorry, what you'll then do is you could actually, sorry. Oh, sorry, hold on. Give me 1 sec. Just now, things stick. Just give me a minute or two. It'll sort out. It usually does. Cool. Just now, guys. I'm trying to get this thing to work. It's not cooperating right now. Oh, okay. Hold on. Okay. We seem to be back in here. Right. Okay. So what I was saying is, if you wanted to triple check, what you could do is you could take the 18 and the 27 and sub them inside equation 2. So you could do 7 by 18 plus 8 by 27 and see if you get 342. 7 by 18 is 70 plus 56, which is 126. 8 by 27 is 160 plus 56. That's 216. Yeah, and 126 and 216 is 342. Right? Now that part there is not absolutely necessary. Right? You could use it. Okay, cool. All right. So in class, people, are we okay with the simultaneous? All right, good. All right, ladies, are we okay with that? Any questions? Anybody? Anything? No? All right, Google Meet. So Christian, Liam, Donovan, D'Angelo, and Logan, if you guys are good with that, just kind of give me a genie chat, please, and thanks. Oh, okay. What? Fast and Furious, boy. All right, cool. All right, so that's the end of question. That right. Okay, so we have a construction thing here. I don't really have the capacity to do constructions with this app, unfortunately. Just now. Okay, I could tell you how to do this kind of easily, right? I'll talk you through it. If you have your implements, you could do it. If not, don't worry. Try it the next time. Yeah. Shucks. All right. Was that the construction or the algebra? All right, cool. Yeah, that look good to me. All right, guys, just give me a couple of seconds. Right. So we have. Hold on. 171. Right. So 7 by that. Yeah, sorry, no, that's correct. 704 is 11. 700 plus 1197 minus 35 plus the 8 342. Okay, cool. 343.
She doesn't want to the share.
Just a second, eh?
256.
No.
Yes.
598
Oh, well,
All right, Nyla, check the subtraction. We are bracketed off. I think you did. So you have 598.5 minus 342. And I see in 253.5, and I think it should be 256.5. Check that piece on, right? Right. Okay, right. So in triangle ABC, AC is 8, BC is 5. Using a ruler and compass only, construct triangle ABC. The line AB has been drawn. Okay, so when it's just lengths they give you, what you do is you take your compass, you put your pencil inside, and you take it and you open it up. So you take your ruler, right? So that's 0, that's 8, and you open your compass to a radius of 8 centimeters, right? You put your compass point here, and then you're going to make an arc somewhere in the distance, right? And then now you're going to close it down to 5 centimeters, and you're going to go here, right? And you're going to make a next arc. And where they cut that point there, that's point C, right? And then thereafter, what you do is you close up your triangle. Right, now this diagram is definitely not drawn to scale, right? So that's 5 centimeters. That is 8 centimeters, right? Okay, cool. All right. I measure and state the the value of angle BAC. Did anybody do the diagram? Can they give me the measure of BAC, please? 45? All right, cool. All right, so. No, you need to use your compass and a ruler. That's what it said. That's the instruction. Using a ruler and a compass only. Sorry? Right, so you put the pencil in the little thing and you tighten it. You don't have it? You have a compass? Make sure the points line up as close as possible. You don't want to leave row. Line it up. What you do is you open this.
Oh, I imagine it's a
Okay, cool. Hey, Jake, when you ask me if I know what football, is what your name? Sure. All right. Okay, let's go on to 3B. Aha! Let's take a read here, and I'll give you a minute or two to try it, right? So, the diagram below shows an equilateral triangle. What is an equilateral triangle, gentlemen? Desiree, Javier, Jaquan, what is an equilateral triangle? Well, all the sides are equal, and by default, therefore, all of the angles are also equal. What is the sum of the interior angles of a triangle? And if they are equally or evenly distributed among all three, the measure of each angle, yeah, you will take 180 and divide it by 3, and you will get 60 degrees. So this whole angle here is 60, as is this, as is. But when they drop this thing called a perpendicular, which means it meets this at 90 degrees here, you cut that top angle in half. If you cut 30 and half, sorry, if you cut 6 and half, what do you have? 30, very good. Cash. I don't like these. Which questions, Cash? You like this one here with the triangle or the constructions? Right. So the triangle on this side is 30, 60, and 90. Calculate the value of each. So let's pull out that half of the triangle, shall we? Right. So you have each on top here. Let's just call this piece X. Right. This is 60 degrees. This is 30 degrees. And the base, so the whole base on each length was 13, right? Now, if you drop a perpendicular from the apex here, or from any side, if you drop a perpendicular, it'll bisect not only the angle but the length as well. So basically, this length across here is 13 over 2, which is 6.5 centimeters. And they want us to find, well, small h. Now we have a right angle triangle. Or the triangle. I know, right? It's basic tricks. We'll see how we can help you. Right. So in a right angle triangle, we could use trig ratios. Now, if we had 2 of the lengths, we could find the third one. Do we have, actually, and we do. We do have this length here. This is 13. How do we know that's 13? Because they told us it's an equilateral triangle and the base is 13. So if it's an equilateral triangle, equi means what? Equal. Lateral means side. It's an equal-sided triangle, which means all of the sides have the same length. So if the base is 13, each of the other 2 sides is also 13. So here, we could actually use Pythagoras' theorem. We could also use one of the trig ratios, right? Now, the length we are looking to find is h, right? Now, this length across here is opposite the right angle. What do we call that side again? The hypotenuse. And what do we call this one here? The low hypotenuse. Right? So relative, now it depends. Which angle are we using? If we're using the 30-degree angle, that side is opposite, which means this side will be adjacent. However, if you choose to use the 60-degree angle, this side would be opposite and this side would be adjacent. So depending on the angle you choose to use, right, that will determine which side is opposite and adjacent. The hypotenuse does not change because the hypotenuse is always the one opposite the right angle. Okay, so given that now, okay, so check it. If you choose to use the 30-degree angle, right, this side is opposite and we're looking for the adjacent, right? So if you're using a 30-degree angle, you have the opposite side and you have the adjacent side. You're looking for the adjacent side. Which ratio uses opposite and adjacent? Tan, that's correct. Right? So if you're using a 30-degree angle, you use tan. If you're using a 60, that one is opposite and this is adjacent here. So you could also use tan. But in that case, it would invert. The opposite would be on top and the adjacent would be below, right? Tan, no problem. Right? But the truth is, we have all three lengths in the triangle, do we not? Sorry. We have the other two lengths, not so? We could use Pythagoras or we could use sine and cosine. If you use the 60, this side is opposite, and look, we have the hypotenuse. Which ratio uses opposite and hypotenuse? Sine. Right? If you use this one, right, this side here is the adjacent side and this is the hypotenuse. Which ratio uses adjacent and hypotenuse? Cosine. Right? So I leave it to you. I'm going to give you a 2-3 minutes. Pick which one you want to do. Right? No, I didn't explain Pythagoras, right? What is Pythagoras' theorem? Pythagoras' theorem says that the square on the hypotenuse is equal to the sum of the sum of the squares on the other two adjacent sides. Right? So side 1 squared plus side 2 squared is hypotenuse squared. All right. So you could use hypotenuse. You could use sine of which one again? Sine of 60. Or you could use cosine of 30 degrees. Right? Now you don't have to use all. Pick one. Pick whichever one seems appealing to you and use that one. But just know you could use any of these. Or you could use tan of 30 or tan of 60 as well. Sorry, I forgot those options. Right? But whichever option you use, right? We'll correct it just now. Right, let me just check. Right. Did I not send this to you this morning? Give people one. Okay. Right. Right. How is adjacent on the left side? I came late. Right. If you're using this angle here, this side across here will be the opposite side. And because this is the hypotenuse by default, therefore this has to be the adjacent side. Right? So hypotenuse is always opposite the right angle, right? Opposite and adjacent depend on which of the other angles you're using. If you use this angle here, that side will be opposite. And this side down here will be adjacent. Yeah, you could use sine, cosine, or tangent. Right? Because look, you're looking for this side here, which is opposite to that 60-degree angle, and this side down here is adjacent to it. So that's tan. If you use the 30, right, this side across here would be the opposite side, and this side here would be the adjacent side. So the h would in that case be your denominator. All right, glad to hear you understand D. Sorry, I was doing something. Oh, I still get emails from this man. You hidden what? Yeah. Let's find out. Okay. So if you used Pythagoras, right? So the hypotenuse is 30. So we have 13 squared. Now, it doesn't matter which of the lengths you choose to be side 1 or side 2. It doesn't matter. You could use h as that. All right, so that's h squared plus, so you have a little fraction works. There's 13 over 2 squared. Now, to find h squared, you'd have to subtract, right? And something most people don't realize here is if you are using Pythagoras theorem like this, you could use difference with 2 squares. Because look, isn't this 13 squared minus 13 over 2 squared? All right. Now, the simplest thing, to be honest, is to plug it in your calculator, right? 13 squared is 169. 13 over 2 squared is 169 over 4. Right? So that's 400, 640, 676. Right? So, of course, if you simplify, right, you have 676 minus 169. So 170 minus that will give us 506. So it's 507. Is it? 169 by 4? 169 by 4. Right. Minus 169. 507. Right. And 507 divided by 4. Right. Is 126.75. Right. So there's 126.75. Now, if that's h squared, how do we find h? We have to undo the square. So you had to find the square root on both sides, right? Right. So now, you just square it and you get 11.26 approximately 11.3. We get 11.3, right? So 11.3 centimeters is equal to h. Right? Right. So I'll put a little separator line here. I can do the tan, no problem. I'll do both of them. I'll do both tans, right? I'll do tan of 60 and tan of 30. But let me use sine first, right? Now sine, if you use sine of 60, that's equal to opposite over hypotenuse, right? So sine of 60 is equal to h over 13. So to solve for h, all we have to do is remove the denominator. What is the operation between numerator and denominator? Division. So to remove it, you'll have to use multiplication. So you'll multiply by the denominator on both sides of the equation. Right? So therefore, h should be equal to, so let's see, so sine 60 by 13, right? 11.258, blah, blah, blah. So 11.3 again, right? Right. Right. Now, if it was cosine, it's cosine, oh, sorry, 1 second. Cosine of 30. So that's adjacent over hypotenuse, right? So that's equal to h over 13 again. And again, we'll just multiply by 13 on both sides of the equation. Sorry.
Oh my gosh.
Not Leah? Oh, okay. All right. So h, so therefore, h is 11.3 approximately, right? So as you can see, it's the same value every time. All right. Now, for the tan, so if you use 30, the opposite is this side, and then that's h, right? So we let's use 60 first. That's opposite and that's adjacent, right? Okay, cool. So we use the purple. Right. So if we are doing tan, now, again, I'm just doing it different ways because different people may have done it different ways, all right? So that's opposite h over, well, 6.5. Let's use 6.5, right? 6.5. Right? So now, again, just to find h, we simply multiply by 6.5 on both sides of the equation. Tan 60 by 6.5. So 60 tan by 6.5. 11.25833, right? So 11.3 again. And if we use this one here. Right, so those colors are pretty close. So tan 30 would be 6.5 over h. Right? And what we would then do is you can multiply by h first. Anybody else hearing a child crying? Like off any distance? Or that's just me? Right, and now to solve for h, we divide by tan 30, right? So 6.5, sorry. 6.5 divided by tan 30. $11.258, so 11.3, right? Go down. Right, so whichever way you do it, you get the same answer. But just so you know, we had multiple ways you could do this. And that's one of the beautiful parts about maths, especially with some of these topics here. So I hope Cash found a particular way that she liked. 20 names, yeah. Sorry, I didn't see you guys there. Oh wait, and what about YouTube? YouTube, sorry, Lauren, 1126. Right, Ethan. So what to use Pythagoras or tricks? Mock test Friday. Yeah, right. Sorry guys, I'm not keeping track of my comments. Sorry about that. All right, Google Meet. If you guys are good with at least one of these ways, just give me a quick Genie chat. Please not chat. If you need me to re-explain any of them, it's not a problem, but you gotta let me know. Right, you can say R and give me the color, whether it's green, blue, orange, plum, or purple. Yeah. If you repeat the question. You repeat the question. Yeah, no, that's probably something in the printing. Yeah, sorry about that. Okay. All right, let's see if we can get through. Right, so we have a little transformations question here, right? So somebody was asking about transformations. If we have time to go through it, we do, but if we do, we just sacrifice time spent on other top past papers. But I mean, if it's something you want to do, we could do that. On there. What I want. An interesting flavor. Let's take a read. The diagram below shows three triangles, P, Q, and R. Triangles Q and R are images of triangle P after it undergoes a double transformation. So you're starting off with P. Then you go into Q. And then you go into R. It's going pink to green to blue. All right, so 1, 2, 3. Okay. Describe fully the single transformation that maps P onto R. If you look at P and R, right? Don't they look like the same thing? So same orientation kind of thing, right? So when you have that kind of thing happening, this is a translation. Right? This is a translation. Right? It's not turned, it's not flipped, it's not reflected, it's not smaller, it's not bigger. It's the same size, and it looks like you just took it from one place and put it somewhere else without turning it or flipping it. But you can't just say a translation. You have to say how it got there. How it got there, we have to count the spaces that it moved horizontally then vertically. So what we're going to do, let's pick a pair of corresponding points. 2, 4, 2 out of 4. All right, let's check it out. Yeah, it looks so. Let's pick this one. The corresponding point on the blue triangle is up here, right? Okay, so let's count how many spaces horizontally we'd have to move to go from there first, right? So we go 1 and then 2 to the right. And then going up, we have to go 1, 2, 3, 4 spaces. So this is a translation with vector. So a vector has a horizontal component on top. In this case, it would be 2. It would be a positive 2 because movement to the right is positive. And then the vertical component will be below, and that will be 4. And then be positive because upward movement is positive. Right? So to go from P to R, that is simply a translation. And again, it's a translation. Yeah, translations are nice. Because it wasn't rotated. If you look at R, it looks like you just took P and shifted it. Right? Q, we could tell Q is definitely not just a translation because look at this is the longest side here, right? And look at this as the longest side here. Are they facing the same way? No, they're facing opposite directions. Right? And say, look at this one. Look at the same long side and this long side here. They're also facing opposite directions. Yeah. No, it has to be horizontal on top and vertical below. So horizontal on top and vertical below. Okay. Now, R onto Q. So R to Q is a backwards thing. Right, so that's a reflection. Now, let me explain how we know that, right? Let me get a different color. It's a brightish color, right, okay. If you look at Q and R, they seem to be kind of facing away from each other. They seem to be flipped, right? But you will notice that those two, like this point here are the same relative points, same corresponding points. You'll notice that this point here also correspond, and this one, right? So R is not turned. So Q and R are not turned. They're mirrored. That's a good way to do it, right? True. Downward is negative. Correct. Downward is negative. That's correct. Yeah. So if we count, so 1, 2, 3, 4 spaces there. All right. And yeah, the halfway point is 2. So that perfectly vertical orange line is what we call the mirror line or the axis of reflection. And if you look, it's passing through 1 on the x-axis. So the equation of that mirror line or that axis of reflection is x equal to 1. Right? So it's a reflection. Yeah, an axis. It's a reflection in the line x equal. So it's a reflection in the line x equal to 1. You know, you have to. Yeah. Okay. Oh, we got no. The center of enlargement is not that bad because all you have to do is connect the corresponding points, and where all those lines intersect, that's the center. The rotation one, you have to find the perpendicular bisector of all of the lines that connect the corresponding points. Okay. So Google Meet. So Liam, Logan, Donovan, Deandra, and Christian. If you guys are good with that, just kindly give me a G in the chat. If you need me to re-explain, give me a R. And we have time, so it's not a problem. Okay. Ladies, we okay with the transformations there? The 3 Gs, fellas, we all right with that there? Zian, Paige, Nyla, we okay with that there? All right. Okay. Now we have 10 minutes again, so let's see if we can maybe get through PISA question 4. All right. Yeah, sorry, go ahead. In the line x equal to 1. Yeah. Okay, I guess you can say, but when they say describe fully, if it's a reflection, you have to say in what line or in what axis. Okay, look, we have some simple functions here, boy. Right, so in case that's a little too small, h of x is 5 to the power of x. Okay, so I'll give you a couple of minutes. Let's see if we can get 4 part A done. So we have f F for 4, H of 0, and FH of minus 2. Hey, we could finish this question, man. Right, come, please. So all we're doing is we're substituting 4 inside of this function everywhere there's an x. And same thing here, we're substituting 0 as the power. Right. So what you're doing is you're going to find h of minus 2 first. So you're going to plug minus 2 up inside of here. You're going to put that here. What's a good topic? Or what's a good topic that any guy wants tonight? Yep, yeah. As the man used to say, it's a bad one. Yeah. That's our next Stewie from Family Guy there. Hey, I get a coin and finger heart. Yeah, okay. I'll send one back for you all too. No circles here. Nah. Next week, so obviously Monday is Carnival, so we don't have any class on Monday. So the next time we meet is next week, Wednesday. So I'm hoping to do 5, 6, 7, and 8, which is a tall order, 5, 6, 7, and 8, which means following Monday, which is the 10th of March, circle geometry. Now, actually, if you check my live from Monday, so go on my YouTube, right? Go on my YouTube, the same handle, Adaptation. Go on my YouTube, go into lives, and you should see my live from Monday. And I did a circle geometry question, the May 2024 question. Crazy King, yes. CSEC, yeah. You will say Monday, it was, okay, good. I'm glad to hear that, yeah. So if that's the case, you might be able to check a couple lives prior to that. Hold on, let me tell you when. Oh, good, because I started with Jan 2025. Go through the lives and see if you see Jan 2025, day 3. If Monday was day 4, right, so you're looking for, hold on, Monday was what day? 24? So look for February 10th. Look for February 10th. Okay. Right, let's go. Right, so F of 4 means you plug in 4 inside of here. So 5 by 4. What's 5 by 4? 20, and 2 minus 20 is minus 18. Right. Whoops. Sorry, give me 1 sec. Let me change the weight on that point. H of 0. So that's 5 to the power 0. Any base raised to the power 0 is equal to 1. Right? And then FH of minus 2. So the first thing you want to do is find H of minus 2. So that's 5 to the minus 2, which is 1 over 5 squared. That's 1 over 25. And then you're going to sub that inside here. Come on, man, Philip, leave yourself. Now, you could simplify this in different ways, right? So the understood operation here is multiply, right? So 5 multiplied by 1 over 25. 5 will cancel, and we will get 1/5, right? And then 2 minus 1/5 is simply 1 4/5, so 9 over 5. Either one of those is perfectly sufficient. All right, people in class, are we okay with these solutions on this page here? Minus 18, 1, and then 1 4/5. And Google Meet, give me a quick G if you guys go with that one. We have time for the last page. We'll knock that out and be in a good position next week, Wednesday. All right. Wednesday? Yeah, we don't attend to play, you know. Yeah, it's called Carnival. So we don't have class Monday. Right, where we go? Find f inverse of x. So first things first, f of x is equal to 5 minus 2x. And then below they want ff. ff is you're taking f and substituting it in itself. So you put, this is like how if you had fg, you put g in f. If you have ff, you put f in itself. All right, so I'll give you a couple minutes and I'll kind of browse through this. Well, I mean, yours open in front of you, so any person who for not seen this Khalifa one, that may not far, but I've not seen it. Huh? The MPs. Okay, Shimon, okay. All right. Well, I can't the inverse, the changing of x to y, I'm back. Yeah, the way they explain it is a very kind of, what's the word going? I'm not sure what we're looking for, but it's just like the way it's always done. So I'll see if I can show you a different way, right? This is not the best function to do it with. So all right, because there's more than one way to do it. All right, so another way you could write this function is minus 2x plus 5, right? Okay, so the conventional way to do f inverse is to let y equal to the function. Then you're going to swap out x and y, and then make y the subject, right? First things first that I would do here is I would actually add 2y to both sides, so I have a positive y value. Then I'll minus the x, and then I'll divide by 2. All right, so that's f inverse. All right, another way to do it is to analyze what was done to x. Inverse means opposite, right? So if for f we multiplied x by minus 2, right? So we took x. Step 1, if you follow this person, was we multiplied by minus 2, and then step 2 is we added 5. That's f, right? F of x. To invert that, you literally have to take the value of x and then do the opposite, going backwards, right? To invert means going in the opposite direction, right? So what you could do for f inverse of x is start with this and undo it. So the first thing we will do, how do we undo adding 5? Well, we subtract 5. And then how do we undo multiplying by minus 2? Well, the opposite of multiplying, yeah, is dividing. So what f inverse of x would look like is you would take x, get minus 5 as the first thing, and then divide that whole thing by 2. Which is not what we got. Oh, it's by minus 2, sorry. By minus 2, right, sorry. Yeah, so these two things are the same, by the way, right? Because to explain why, if you factor out minus 1 from the numerator, and a minus divided by a minus is a plus, so you just get 5 minus x over 2. Sorry about the rush. Anyhow, right. And the last thing they want, given that f of x is a plus bx, determine the values of a and b. F of f means just substituting the function f into itself, right? This is what it look like. So given that f of x is equal to 5 minus 2x, f of x means substituting the entire function into itself. So that will be 5 minus 2 by 5 minus 2x. So you're replacing this with the entire function. Now we'll use distributive law to expand the bracket. Minus 2 by 5 is minus 10, but minus 2 by minus 2x is plus 4x. And 5 minus 10 will then give us minus 5 plus 4x. And if we compare that to a plus bx, we can deduce, therefore, that a is equal to minus 5 and b is equal to 4. Cash. For linear functions like this, it'll work. For the rational function, like if you have an x plus 2 over x plus 3, or like a 3x minus 2 over 4x plus 5, yeah, I'm trying to figure out an easier way to explain that. But it wouldn't really throw it off. It might look a little different, but it's not. They only look different. The values are the same. Well, thanks, Rihanna. I appreciate you sharing your life. Thanks very much. Right, ladies and gents, we just did the first 4 questions out of 10 for the Jan 2024 Math Paper 2. Right? We don't have class Monday because it's Carnival, but we do have class Wednesday unless I state otherwise. Whether you're here or not, I'll be here. Right? So whatever you do for the Carnival, be safe, enjoy. If you're working over the Carnival and you have any questions, message me. But just so you know, again, my WhatsApp giving trouble. The notifications not coming through as I go in and open. So if you have an iPhone, you could iMessage me and I'll probably get that. See ya. What? Okay, bye, Julie. WhatsApp me and I'll let her know. Right. Okay. Fellas on. Okay, we'll live on already. All right. Sorry. But for those who are new there, Liam and Logan. All right. So Liam and Logan, I'll see you all next week. Right? Bye. Elena. Oh, I know where Elena is. Them Andrews here, you enjoy. Huh? It was there and I went and take it back.